Today we're going to be solving a hard integration problem, and right off the bat, looking at this, what I can notice is that the denominator here, it's in the form of a to the power of some in the form of some power times c to the form of some power, or a squared plus c squared or root. When this is the case, you can't integrate normally using your u substitution. Like based on your normal u substitution method, integrating like that just won't get you to the answer. So you're going to have to use trig identities and trigonometry to integrate this. So to get started, the identity, we'll take the Pythagorean identity, sine squared theta plus cos theta equals 1. And then from there, what we're going to do is we're going to divide by cos squared theta, both sides. So tan squared theta plus 1 equals sec squared theta. Right, so what can we do from there? It's a form of x squared plus 1, so tan squared plus 1. You can replace that as x squared plus 1. You can just make that equal that. So then x squared is equal to tan squared theta, and then x will just be equal to tan theta. Right, now you have an expression for x now, so what you can do is you can differentiate. So dx over d theta equals sec squared theta because tan differentiates to sec squared. And then dx is equal to sec squared theta d theta. Right, we're actually getting somewhere now. We're getting somewhere. That's good. Now what we can do is the limits are 0 and 1, so we're going to change the limits. Right, so we know x equals tan theta. We want to since we're making a substitution, we're in terms of a trig theta, we're gonna integrate in terms of theta now. So theta, we need to change the x limits for theta. So theta will equal arctan x. So theta will be arctan 0, which I'm pretty sure is 0. Let me double check. Yeah, it is 0. And then theta equals arctan 1, which is pi over 4 radians. So we can rewrite, we can rewrite this, essentially. This can be rewritten as, okay, x squared is just tan squared theta. And the new limits are 0 and pi over 4. And then sec squared theta can be x squared plus 1, tan squared plus 1. So we're going to say sec squared theta cubed multiplied by sec squared, is it sec squared? Yeah, sec squared theta d theta. Okay. We simplify this out further. This should be, that looks like sec 2 theta, sec squared, yeah. Sec 6 theta d theta. Right, now we're in a pretty good place. So what we can do now, I think, is we can simplify this further. So let's get rid of this and make this a 4. Right, that's good, we simplified it. Tan squared theta is sine squared theta over cos squared theta. So sine squared theta over cos squared theta divided by 1 over cos to the 4 theta d theta. Because sec theta is 1 over cos theta, so we can make that change. Right. Now, this is just the same as multiplying by cos to the 4 theta. This cancels out, this becomes a cos squared. So that's sine squared. Okay, that's lovely. We've got sine squared theta, cos squared theta, d theta. Right. This reminds me of another identity, actually, the compound angle formula. So if we use the compound angle formula for this, the compound angle formula is sine 2 theta equals sine theta cos theta. 2 sine theta cos theta. So if we divide by 2, we get sine theta cos theta. And then we just square both sides, which would be sine squared 2 theta over 4 equals sine squared theta cos squared theta. Okay, that's perfect. Now we can put this into this. So 0 pi over 4 sine squared 2 theta over 4 d theta. Right, we're one step closer to achieving our solution. I'm just thinking what to do next, actually. So this is still not suitable to integrate because we've got a sine squared term there. So it's really not nice, but we can use cos. We can actually use the cos of 4 theta. That's just the same as cos squared 2 theta minus sine squared 2 theta. And if we, or cos squared 2 theta is just 1 minus sine squared 2 theta. So 1 minus sine squared 2 theta, take away sine squared 2 theta, equals 1 minus 2 sine squared 2 theta. Great. That's cool. We got sine squared 2 theta here, so we can rearrange. So 2 sine squared 2 theta equals 1 minus cos 4 theta, and then sine squared 2 theta will be a half times 1 minus cos 4 theta. A half multiplied by half is the same as dividing by 2, so let's just make that a half minus a half cos to the 4 theta. Lovely. Now we can put all of this into this, but we're not done yet. It's over 4. So what do we have to do? We have to multiply by a quarter again, or divide by 4. Divide sine squared 2 theta by 4. So we're just saying a quarter dividing by 4, half minus a half cos to the 4 theta d theta. Right. This will be 8 minus a 32 cos to the 4 theta. Right, this is perfect. Now this is in a good form, so we can actually differentiate this. No, what did I say? We can actually integrate this. This is good. We finally, through some meticulous trig integration, we finally reached a form where we can evaluate this. So an 8 theta minus a quarter. No, it's not 32. Why the Right, so we got to this point, we're almost finished. All we have to do is just finish evaluating this integral. So if we quickly do that, that's an 8 theta minus an 8th multiplied by a quarter sine 4 theta. That's evaluated between pi over 4 and 0. So let's simplify that further. So that's this. Great. Right, so that will just be an 8 times pi over 4 minus 1 over 32 sine 4 pi over 4. Take away, well, if we input theta as 0 here, that will just equal 0. So we can neglect that part. We can just save that part. So let's finish this off. Pi over 32 minus a 32 sine 4 pi over 4. Yeah, that's just 0. So we finally got to the point where we proved this integral is equal to pi over 32, which is what the original question, I think, instructed us to do. So we finally got there. We used a bit of meticulous trig integration. So it was quite hard to spot. You had to be quite creative with this one. And I think it was overall quite fun. So thanks for watching.